going to be indoor air quality. And first, we'll start off with a little bit about the H.L. Turner Group. We are a full-service engineering and architectural firm based in Concord, New Hampshire. We focus on occupant health through our designs. It's one of the things we're very passionate about, and we know that if a building is not functioning properly, the people inside will not be taken care of, and they won't be optimized for either whatever task they're doing, and it'll have a negative impact on their health and wellness. So lately I've been performing indoor air quality assessments in large industrial facilities, commercial buildings, as well as some residential homes. We've been providing assessments in various buildings since 1993, so that leads us to almost 30 years of experience. I've been in hundreds of buildings, figuring out what's wrong with their indoor air quality and how to improve it. One thing that we've learned is every situation is a little bit different. So my sort of caveat to the whole conversation today is I'm going to give some general guidance that's based on CDC and some other governing bodies, but every situation is a little bit different, and that's where having an assessment by an engineer or an indoor air quality expert would be helpful, because every situation is a little bit different, and we pride ourselves in being able to tailor solutions to our clients. Robin, do you want to start our talk now that I've done a little blurb about
Sure.
our company? And
yeah, this is great. And I thank you again. And the Turner Group has been really great supporters of Plan New Hampshire as well. And I really appreciate that, that you took the time to do this today. So indoor air quality, we've always been concerned about it. But right now there's a lot more people looking at it and trying to figure out ways to manage it. And as lay people, as a layperson, say I'm a town manager, or I run a building, or I have a business or something, and and I want to bring people back in, and I know I need to be thinking about air quality, but why is this important, and what kind of questions should I be asking?
That's an excellent question, and one that I agree everyone's thinking about. It's one that we're currently thinking about as we're looking to bring back our staff into our own office, and what that looks like for us. So one of the things that I've kind of reviewed a lot of the documentation that's been out there in the media provided by the CDC, ASHRAE, which is the American Society of Heating, Refrigeration, and Air Conditioner Engineers, and also some of the World Health Organization documentation. And the main thing that they seem to focus on is managing pollutants inside the space, which is at the point source. So we're talking about a virus here, COVID-19 virus, but it also applies to other viruses and particulate that we've been dealing with for years. But that's where the masks come in as the first step, stopping that particulate from leaving your mouth and getting out into the space. So that's your sort of first line of defense, and that's why they're recommending masks, because it keeps the larger particulate from traveling through the space. I was doing some research on this subject last week and came across a study with how far a sneeze actually travels if it's not obstructed, and the particulate can actually travel upwards of 24 feet. So it's much more than the 6 feet of social distancing that they're recommending. You wear a mask, it'll capture the large particulate and thus reduce that spread of potentially damaging particulate. So ASHRAE, the CDC, is recommending increasing the ventilation rate, so the amount of outside air you bring into the space. So that's through your heating and cooling system. One of the reasons why they're pushing for that is if you can increase the amount of ventilation, you dilute the amount of particulate in the space. So the air you're breathing out, if you're coughing, all that stuff, it's going to be generating small particles that are going to stay in the air. And it's sort of using the approach of the solution to pollution is dilution, which is partially true, but that's what they're really trying to get at, is getting clean, fresh air to where you're going to breathe it and get rid of those bad particulates which sort of steps into the next one, which is filtration. Most HVAC heating and cooling systems have a filter in them. They are varying degrees of effectiveness in their filtration. They're based on a MERV rating, which is the minimum efficiency reporting values as defined by ASHRAE. And most systems are a MERV 8, which is, it's on a scale of 1 to 20, 1 being the lowest, 20 being the highest. Clean rooms, operating rooms, those types of spaces use a HEPA filter, which sits at a MERV 16. And a HEPA filter can capture 99.97% of viruses and other small particulates, versus a MERV 8 filter, viruses, small particulates will travel right through it. It does not have much or any arrestance at that filtration level. So ASHRAE and the CDC is recommending a MERV 13 or greater filter. At MERV 13, you start to capture larger virus particles. It's also a filter that can be relatively easily retrofitted into most heating and cooling systems. Obviously, if you could, I would recommend going all the way up to a HEPA filter. You're going to capture more particulate, you're going to capture more viruses that way. But if you can do anything to increase above a MERV 8, you're going to be better off than before. So the CDC, ASHRAE, they're sort of using a three-prong approach. You know, it's managing pollutants where they're generated, i.e. wear a mask, filter the particulates that get out into the space, and then also increase your ventilation rate as much as possible to try to dilute any particles you have in the space and then remove them through your exhaust system. One of the things to note is just make sure that where you're drawing your ventilation air is from a clean source. We've seen outdoor air intakes that are close to where you might have a truck idling or a buses idling or different cars. There can be also, you know, it could be near your dumpster. So just make note of where your outside air intake is and make sure that it's very protected, because that's going to be one of the keys to keeping your inside environment safe. So the next sort of piece to this is how well does your heating and cooling system actually work, and what does it do to the particulates in your space? So on the left, you can see a more traditional heating and cooling system. You're supplying air at the ceiling level, and it is basically fully mixing that air in the space. So particles are able to move freely throughout that space. The air is pretty uniform in temperature. It's a very effective means of heating and cooling. It's the traditional way we've been doing it in the US for decades. On the right-hand side is a slightly different system. It's a displacement air system. And what that does is it supplies clean, fresh, 100% outside air, low, down by the user at a slightly cooler than room temperature air. And what that does is the cool ventilation air tends to pool at the floor until it hits a heat source, such as a person, a computer, something of that nature. And then it tends to rise up along that person using natural convection. And what it does is, as it's going by the person, it tends to take the small particulate matter that they might be generating from breathing, coughing, and it'll draw that up towards the ceiling. So this is a slightly different system. It takes more of an engineered approach. It can be retrofitted into schools, commercial buildings. We've done it in a number of schools where they had a traditional ceiling system, and we were able to modify it through providing displacement diffusion as well as controls and some other various pieces, parts. But it tends to involve an engineer and architect to make the system work. So these next pictures, on the left-hand side is the displacement ventilation system supplying the air down at the floor level, right where the person's going to be breathing it. And as you can see up near the ceiling, this is the left-hand picture, up near the ceiling there's a higher amount of particulate, but that's above where the person is standing. So they're not going to breathe that in. It's going to be buoyant and up at the ceiling, and then it's going to be drawn into the return system, which it'll be captured hopefully by your HEPA filter in your air handling system or fully exhausted out of your building. On the right-hand side, you have a fully mixed room with the particulate pretty evenly spread throughout the space. So if it were me, I'd want to be on the one on the left because I'm going to be breathing cleaner air, less particulate. On the right-hand side, it's an efficient means of heating and cooling, but it's also distributing those particles around the entire space. So there have been some studies that show that the HVAC system is partially to blame for the spread of COVID-19. It's harder to quantify some of those studies, but it's fairly easy to see from at least these two pictures, why you might have a particulate issue with a more traditional HVAC system. Does that kind of cover what you were looking for, Robin? Where we were going?
I think so. This is really interesting.
Questions?
So the one on the right here, that's probably the more traditional system. So that's probably what we see in a lot of the buildings that exist now.
That is correct.
Okay, so places like nursing homes and offices and schools and places like that, that's what exists now. So what could people do within an existing building that they have now? What is it that some folks could do to make it better without coming in and having to totally overhaul the whole thing? Or is it something that it sounds like, because every case is different, should probably have somebody come in and take a look and say, based on how high it is and your uses and the airflow and the number of windows and all that, that probably makes a difference, right, as to what could be done immediately. And then also, what are there things that we shouldn't be doing that seem to make sense but really don't?
Those are great questions. If you have the system on the right, which 95% of the people in the US do, one of your methods you could do it would be a local HEPA filter, a local floor mounted unit, wall mounted unit that recirculates in the space. And what that would do is it would help to reduce the amount of particulate that then is spread throughout that space. So, people will have indoor air purifiers in their house. They're fairly easy to come by. And it's a relatively low cost system that has a pretty good effect on the overall space indoor air quality control. It's not the end all be all, but it is a good stopgap measure. I was on a ASHRAE call last week, and they did some computer modeling, computer simulation of airflow and particulate movement within an office space. And they found that by placing, in this case, it was 6 localized HEPA filters in the space, which is a fairly decent amount, they were able to capture and reduce the particulate levels significantly. So that is one way of doing it. My vote is, as we move forward making new buildings, we take more care in how we're distributing the airflow. Europe has been doing displacement air for over 20 years, and it's fairly commonplace over there, which is where the H.L. Turner Group came across it 30 years ago. Bill Turner was over in Europe on an indoor air quality at an indoor air quality conference, and it just clicked for him, and he brought that back to the United States, and we've started in the 90s doing it in a lot of schools and classrooms, and we've found that it dramatically reduces sick days, things like that, because you're providing clean air right where you're going to be breathing it and reducing the pollutants that are getting discharged and moving them out of the breathing zone up near the ceiling, where it's then returned to the unit, filtered, and then provided back into the space or sent outside.
I'm surprised. I'm sorry, go ahead.
I have a question related to the new induct UVC systems, and
Sure.
do you have any input on those? We've been getting a lot of requests for pre and post installation IAQ testing, but I just wanted to see what your thoughts were on that.
Those, they do work. What we've found is that you need to have a very high intensity UV bulb. It's not, a lot of people use UV lights on their heating or on their cooling coils to prevent bacterial growth on the cooling coil. And in that situation, you don't need to have as high of an intensity because you're just trying, it's a more steady state environment. When you have it in your ductwork, your airflow could be anywhere from 500 feet per minute to 1500 feet per minute. So the air is moving very quickly through that ductwork, and there's a certain dwell time, contact time that the particulate's going to have to see to be able to sterilize it. So it can be effective, but it needs to be properly designed, and it's a very intense bulb that you're going to end up needing. There are some very good vendors out there that can easily design you a system that will work. There's also filtration, active filtration you can get that helps to, it helps the molecules, the really small particles in your space to conglomerate and get larger. And then what that does is it allows it to be drawn into the HVAC system and then captured more effectively by the filter. So they both work. My opinion is I'd rather use the filter with the activated coil. I think it works a little bit better, but both systems can work if they're properly engineered.
Cool, thank you. So, Tom, what are some things that we shouldn't be doing?
That's another good one. I saw some pictures of a school retrofit that they put up plastic dividers throughout the classroom up to about 6 feet around the desks. It was closed off, I believe, on 2 sides, sometimes in some other cases 3 sides. And it had a ceiling supply, ceiling return for the HVAC system. And my concern there is just over your airflow patterns. Are you going to get proper airflow around those walls? The system wasn't designed for that. Another scenario I saw is there was a restaurant putting up plastic sheeting around a booth to help to socially distance, let's say, their tables. What that will end up doing is capturing all that particle, all the particulate matter inside that booth. So yes, it might, if you had COVID-19 and you were in that booth, you might not spread it to the adjacent spaces, except for maybe to your server. But then when you leave, if they don't fully sanitize that plastic sheeting in that booth where you had a high amount of particulate concentration, it's gonna end up spreading probably to the next group that comes in there. So there's a lot of sort of misinformation. It's taking the mask approach and just applying it to other things, versus the mask is really just to try to keep any particulate in you and not spread it. And that's where really ventilation and filtration, capturing the particles, diluting the particles, removing the particles is really sort of the best method.
Robin, can I ask a quick question directly related to the idea of separation of students in the school using some type of panel? So I run a community music school, and we're looking at the possibility of doing summer camp with youth students who play wind instruments, limiting the participation to only 8 students in an 1,100 square feet space that has about a 14-foot high ceiling. Mm-hmm. It's got the I guess, bad type of ventilation, the traditional type of ventilation coming from the ceiling down. One of the things that we've been looking at is using plexiglass drum shields. I don't know if you've ever seen these. They're typically used for sound around drums, and using those to isolate each of the players around the room so they don't rise too high. They're probably about 5 feet off the ground is how high they raise, but it allows the child to sit behind the plexiglass shield and play a trumpet and potentially reduce the particulate circulating around the room. The idea is that those 8 students would be the only 8 students to have access to that room for the entire week. They would have their one station that they would be in, no other person would be in that station, and that the plexiglass would be wiped down daily by the teachers wearing gloves and masks, and then the space would be cleaned on the weekend before another group of students came in. So we're trying to find a way to allow kids to make music together safely and not cause additional problems. Do you have thoughts on that?
I do. I think that makes sense to a point. My concern is you're still going to have particulate that's going to want to, the lighter molecules will rise up past the plexiglass. up into the main room. So my thought is, and this is just off the cuff, potentially putting individual floor-mounted HEPA filters in each one of those sort of drum cages. That way you're at least reducing the amount of particulate that's going to build up in that space and then spill over to the adjacent rooms. I'd have to think about that one a little bit more and potentially look at the layout. But that's my initial thought for an easy way to at least make the situation better. Playing instruments, singing, things like that, you do send particulate matter very far. So it's good that you've identified that issue. So, you know, that's great. But that is one of the tough ones because you're going to project. And, you know, one of the things is, you know, choirs, things like that. They found that you're going to spread the particulate everywhere just because you're projecting with your voice. So I'm sure that's the same thing with a wind instrument. Does that kind of answer your question?
Yeah, it does. I mean, the initial research that I've seen that's not yet peer reviewed is that the wind instruments aren't nearly as bad as vocal singing, but okay, they're doing some studies this summer that some of the organizations I'm in have invested in to try and see if they can come to any conclusive data on that. Sure. You know, the real concern is not having to wait 2 or 3 years before a group of 8 kids can get together in a safe space and actually be able to make music together.
I 100% agree. And the tough part is there has not been a lot of studies done on larger particles and how they travel. A lot of the data that we have is from 1930. There was a lot of studies done on particles from coughing, sneezing in the 1930s. And unfortunately, people then focused on extremely small particles, nanoparticles, or they got to more larger pandemic type, you know, how does it move around the globe type situations. And they didn't focus as much on the actual particle that comes out of our mouths, things like that. So everybody's sort of scrambling right now to get more data on that. So I agree, it's a tough one. And I have kids in school and they want to go back to school because they miss their friends. And it's a very difficult one. Everyone's trying to do their best, but it's difficult. And, you know, and that's where bringing on an indoor air quality expert or an engineer can help because we sometimes bring in a fresh perspective and maybe think outside the box, and we'd work obviously collaboratively with you to come up with a situation or this right solution, because every situation is different.
Thank you.
Great. Thank you.
We're going to do, I'm just doing a time check. It's 9:28 and we do have a couple of questions to ask. Tom, is there anything else before I go to the questions that you want to include or add?
Yeah, the only thing I was going to add is there is some good documentation out there right now from the CDC. ASHRAE has a COVID-19 help link, which is located here. It's just ashrae.org/COVID-19. And ASHRAE has committed to responding to questions based on indoor air quality, filtration, HVAC, things of that nature. They try to respond, I believe, in under 2 days, was what the task force said when I was on a call last week. So those are some really good resources. ASHRAE tends to do a deep dive on a lot of the information, which is good because they've done their research, but it also can be a little tedious to weed through. But those would be my last sort of 2 thoughts is, you know, utilizing the CDC resources as well as some of the ASHRAE resources that are available.
Okay, and I do have some questions that were asked during the talk. Nicole asked a couple of things. I think you addressed one of them. Isn't the mask also useful to prevent the airborne particulate from coming into your mouth and nose, even if it's not an N95 mask?
That depends on the particulate size. The larger particles, yes. What happens is, let's say it's a low humidity day, or even, you know, it's inside the building in the winter. You cough and sneeze, that particulate, which once was relatively large and would have been caught by the mask if you were wearing it, tends to evaporate and become a very small particle, but it still has the virus in it. But what happens is it becomes even smaller because the water on that particle has gone away because it's evaporated due to the low humidity. And then at that point, that particle now has changed size, and what would have been arrested if you had been wearing a mask and coughed is now going to pass right through the mask that you're wearing if somebody else wasn't. So that's where it's a tough one, because it really has to do with particulate size, and is it evaporating and getting smaller, or is it staying the same?
And I think that answers the rest of her question as well. She states, isn't the mask useful for the user to prevent obtaining the virus, even though the CDC has not been willing to say that?
Right. Yeah, and it comes down to particulate size.
Right.
And that's where we're really pushing for everyone to wear it, not for yourself necessarily, but for others, because as you cough and sneeze, the particulate has not had a chance to get any smaller, and it'll most likely get captured by your localized mask.
Right.
Which
She
is
has
a little
another
backwards
question.
to most thinking.
Yeah. She has another question that I'm going to save for the end. And then we got a question, along with filtration, would there be value in UV lighting?
There would be. It would most likely depend on the level of filtration. If you're already doing HEPA filtration in your system, it might not be any beneficial to add UV light on top of that. But if you had a lower level filtration, let's say you're a MERV 10 or even 14, 13, it will still have an advantage at that point, because you still will have the small particles that will be able to travel through. But then once again, the UV has to be of enough intensity and have enough dwell time that it can actually sterilize what's passing through the airstream.
Right. And then the last question, again from Nicole, is H.L. Turner available this spring and summer to do quick building assessments for town halls? And are there grants available to help them do quick physical HVAC upgrades this summer and fall?
To answer the first question, yes, we're available. To answer the second question about the grants, I do not know. That's something that we can look into. As everyone knows, it seems like the government funding for various things keeps changing. So there could have been something released recently. As of right now, I don't believe there is, but that obviously could change. So we can look into that.
And I would suggest also checking out the CDFA, it's grants, and they're also, to Tom's point, there's a lot of money coming in, but we're not sure yet exactly how much and what it's for, but they've got grants for communities to do stuff. And I don't know if this would fall under that, but they're a good starting place. And also your planning commission would be a good resource to go to if you're a member of your planning commission, to find out if they know of any resources too. Yeah. How are we doing for time, Heth?
We are at 9:34, so we're slightly over. I think if anybody else has other questions, Tom is willing to stay on for a little bit longer, or if anybody else wants to contribute any comments that they've come across regarding this subject. You're welcome to unmute yourself if you have a question or want to contribute.
I do have one more question. Can you hear me?
Mm-hmm. Yes, and who's this?
Nicole Gage, Towns of Sunapee in New London. I'm working in 2 offices where they are retrofitting a lot of plexiglass for customer service counter windows. And I'm surprised to see this assumption that a plexiglass barrier that has a large 10-inch, slot on the bottom to pass papers, as well as a big opening, 8 feet higher and up. And I've expressed concern like, the thing is the people coming in and they're breathing in, it's just all coming in. If you were doing a plexiglass barrier for customer service window, one person behind, doesn't it make sense that they're talking between fully enclosed rooms, like fully enclosures, so the air can get clean on either side, it can be sanitized, one person only? But what's the purpose, even at the grocery stores, how helpful is that plexiglass that's surrounded by open air? That's all.
Yeah, and I believe that the only thing it would really stop would be is if somebody were to cough in your general direction or sneeze, or a lot of the smaller particles will be mixed by the HVAC system and will go around it. But if you were to cough or to sneeze at that plexiglass window, it would arrest it before it got to the person behind the plexiglass. So once again, it's the large particles that we're ultimately trying to capture with a mask. So it's one of those, I think if everyone were wearing a mask, which I hate wearing a mask personally, but I get it. If we were wearing a mask when we went to the store, we were wearing a mask when we went to the town offices, that plexiglass, I think, would become irrelevant at that point and wouldn't serve as much of a purpose because it doesn't do a good job of necessarily isolating from the smaller particles, which will just eventually get transmitted around it, but it will take care of the larger particles.
Thank you. I know it's not an HVAC thing.
I think it is though, because of the fact that it's the first step that everybody's taking right now is plexiglass in the furniture industry, and every manufacturer is coming out with plexiglass stacks, and you're seeing them in every convenience store and gas station and grocery store and bank everywhere. And I think there's a need to get the word out about HVAC upgrades and filtration versus this plexiglass push.
Go ahead, Russ.
Just a quick clarification question. The two types of systems you mentioned, the one that's less common, is that called a displacement ventilation system, or is there another name for that?
It is a displacement ventilation system.
Okay, thank you.
Yep.
And what was the system that you recommended that you said H.L. Turner discovered the Europeans were using? Well, you showed us 3 images, and we really hovered on last really bad one. Was one of those a displacement system? Oh, thank you.
Yeah, so
Yes, okay.
the one on the left is a displacement air system as well. And we are fortunate in that we have this actually in our office. The little silver thing kind of over my shoulder here, that's one of our displacement diffusers. So we have it in our office. We've done studies in our office and other spaces. And that's what we would recommend. We've retrofitted it into schools. There's a lot of advantages to it, but it's a different way of designing. I've been with the H.L. Turner Group for a little bit over, coming up on 2 years. And before that, I did large industrial. I also did schools, institutional buildings, that type of stuff. I'd been around displacement air a little bit, but I didn't truly understand it. So it was very easy to dismiss it because it was something different and it wasn't the norm. And I just said, oh, that can't work. Being here, learning from Bill Turner, Steve Caulfield, the other individuals on the team, they've been doing it for over, coming up on 30 years. And they've got smoke testing that they've done. They've got real world testing that they've done. They've got supporting data, things like that. And it's hard to refute it. And so I really did a deep dive when I came on board here, coming upon 2 years ago. And there's a lot of documentation that it does work, but it's still something different. So we're less, in tune to install it and do it. And you do need to take a little bit more care with the design because it is different. It's not to say that we can't all pick it up, but it's just a slightly different type of system. And sometimes we're resistant to change in the US, it seems like. I know personally, since I've been in this office, I have had less sickness, less allergies, less issues in the last 2 years than I did in the previous 15 years in office environments.
Question for you, to retrofit an office with a displacement air distribution system, is it complicated? Is it simple?
It depends on the office arrangement and type of system they have.
Okay.
It could be relatively easy, but it also could be very complicated depending on floors, how the air is distributed, where the ductwork is, what type of HVAC units you have. And that's kind of where the CDC and ASHRAE has landed on increased filtration and increased ventilation rates, because those are two that are relatively easy and inexpensive to implement. What I'm sort of pushing for is going forward, let's think a little bit more about how the air moves through our buildings and let's design it differently and better. Because COVID-19 behaves very similar to the virus, regular flu virus, things like that. you know, it would be great if we could eliminate that as well through better building designs, things like that.
Great. Well, thank you so much. Thank you so much. And thanks to all of you who came and participated in this great conversation. We're really glad that you were here. We invite you, if you do not belong to our distribution list, our mailing list, to join our mailing list to get updates on what's coming up next. We also encourage you to consider becoming a member of Plan New Hampshire, which would be great. But thank you, Tom, and thank you, Heather, and thank you all of you for being here. And we hope that we see you again. We're going to sign off now, but if Tom and Heather could stay on for a few minutes, that'd be great. And to all the rest of you, thank you and have a great day.
Thanks, Robin.
Bye, Russ. Okay, good.